Folks, welcome to the webinar. We'll be starting in about 60 seconds. Chris, I'm not seeing the record button.
Yeah, I see a record button by your name, Jeff.
You do?
Yeah.
I'm not seeing it. Where'd it go? Start video.
Hit the participant button there.
Can you hit the
Still
record
have some
button?
people coming in.
Is it letting you hit the record button?
It doesn't do anything when I do it.
Oh, for goodness sake.
I think mine says it looks like it may already be recording. In the upper left, we have a little green or little red.
Yes, thank you. Thank you. Good. Okay, we're good. Chris, take it away.
All right. Well, welcome everybody. And of course, with the use of technology, we're still working out some kinks, so appreciate your patience. And thanks for tuning in today. I'm Chris Martin. I'm the State Forester for Connecticut, the Department of Energy and Environmental Protection. It's been a great privilege for me professionally to be working on the Governor's Council on Climate Change and to welcome you to the Exploring Climate Solutions webinar series, which highlights innovative climate change solutions in Connecticut and beyond. The series provides firsthand accounts of high-profile municipal climate change programs, climate initiatives in the corporate world, new greenhouse gas reporting frameworks, statewide sustainability programs, low carbon fuel initiatives, and other programs and projects that help reduce greenhouse gas emissions and improve climate resilience. To see any of the 40+ previous webinars, check out the archive on DEEP's website. The archive URL will be on the screen. You can take a look at that. In New England and across the nation, the use of concrete and steel is primary to building materials results in a large embodied carbon footprint for our buildings, especially in urban areas. In today's webinar, we're glad to focus on New England Forestry Foundation's Build It With Wood initiative. Build It With Wood aims to reduce the carbon footprint of new mid to high rise construction by replacing concrete and steel with engineered timber products. Our guest is Jennifer Shakun, climate forest specialist at New England Forestry Foundation and leader of the Build It With Wood initiative. Presentation is about 40 minutes, and then we'll take some questions from the audience. If you have a question, please submit it in the Q&A box, and I'll read it aloud so our guests can respond. If you're listening via computer audio and experience poor sound quality, I encourage you to call in using your telephone. And again, we did experience some technical difficulties. The presentation is going to be presented to you in a PDF format, so you may need to adjust your screen size for proper viewing. Jennifer, with that, I will turn it over to you.
Okay, well, hi everybody. I guess I want to just quickly start by saying thanks to the organizers for inviting me to participate in this webinar series. I'm really happy to have the chance to talk with all of you today. And I really want to focus on, how we can combat climate change by building with wood, if we link that building simultaneously with strategies for land conservation and improved forest management, and to try to give you a sense for how that might work in our region. And as Chris mentioned, this is you're looking at a PDF of the presentation, so as we go through, there's a few places I'll point out to you where things may get a little wonky without the animations, but you'll get the idea. So next slide, please. So I just wanted to start by giving you all a little bit more context of New England Forestry Foundation as an organization. We are a 75-year-old nonprofit founded in 1944 and started really because the founders weren't happy with the kind of forest management they were seeing in our region, and they wanted to model something better and help other landowners do the same. And so NEF is a little bit of a unique organization having this dual mission of conserving New England forest land, but also promoting exemplary forest management. And we see those two pieces, conservation and management, as really complementary, and they're both critical, to sustaining wildlife habitat, prosperity, beauty, really the unique character of the New England region. Next slide. And so I like to start often by showing you these images, which are partly hidden, I apologize, and kind of asking you what you see. And so since you can't see them fully at the moment, I'll tell you what's there. And you're seeing images of stronger coastal storms, wildfires, forest mortality due to insects, mild winters. And the reality is that this is how climate change manifests itself on a local level. And these are the impacts that we're up against. And climate risk is really tricky because it's systemic. There are direct, indirect, and interacting effects that propagate throughout our economic and natural systems. It's non-stationary, meaning that our understanding of how systems operated in the past may not be a good predictor of how those systems will perform or respond or behave in the future. It's non-linear, meaning that once we cross certain thresholds and tipping points, the impacts grow considerably. And the Department of Defense has called climate change a risk multiplier. It tends to amplify existing threats that we're facing. And it's regressive. Its impacts are felt disproportionately by the most vulnerable populations. And so it poses risks both to society in terms of human health, security, infrastructure, those climate justice type of concerns I was just mentioning, but also risks to our natural systems. There is more and more evidence of climate-driven forest mortality happening across the globe, driven by drought, extreme heat, changing pest and disease dynamics. And species are migrating in response to changing temperature and moisture conditions. In some cases, that's leading to extinctions or local extirpation. So while the problem of climate change has been known and understood for a long time, more recently there's been a realization that a lot of the projected changes are actually happening faster than scientists predicted. And so the urgency of this challenge really can't be overstated. Next slide. So with guidance from scientists, policymakers have identified some thresholds of warming above the pre-industrial average global temperature, beyond which the level of warming is considered to be dangerous in terms of its impacts on people and the planet. And those thresholds are 1.5 degrees Celsius and 2 degrees Celsius. So the figure you see here is from a recent special report from the Intergovernmental Panel on Climate Change that looked at the difference between hitting one or the other of those thresholds. And so in gray, you see average global temperature over time. And then these shaded areas to the right are showing you different potential futures. And the take-home message is that we're on track to hit that 1.5 degrees C threshold somewhere between 2030 and 2052, which is right around the corner. And if we want to avoid going over that, we have to go to net zero carbon emissions globally by 2040. If we push things a little farther and just try to keep it under 2 degrees C, we still have to go to net zero by 2055. So the scale of mobilization and kind of bold action that's required to achieve this is really incredible. And we have this really critical 20 to 30 year window in front of us to avoid some of the more catastrophic impacts of climate change. So the forest-based solutions I'm going to talk with you about today are really focused on trying to make a difference, particularly in that 20 to 30 year window. Next slide. But it's worth noting that at the same time, that we are facing this challenge of climate change, society still has a need for sustainable raw materials. And every sector, including the forestry sector, is having to think about how we can practice the 3 R's, reduce, reuse, recycle. But that can't get us all the way there. There's still going to be some unmet demand. And the question then becomes, how do we satisfy that demand in a more sustainable way? And so, I've just thrown up here off the top of my head some of the many ways that we use wood products in particular in our everyday lives. Some of the most salient in recent months are probably things like toilet paper and cardboard packaging, for all those Amazon packages arriving at everyone's doorstep. But this is really another need that we have to satisfy in addition to the challenge of climate mitigation. Next slide. And so, more and more, our forests are being asked to really do both of these things simultaneously to help us mitigate climate change and provide renewable raw materials. And the good news is that forests are one of our best natural solutions to climate change. I mean, there really is no more cost-effective way to pull carbon out of the atmosphere than to just let trees do what they do naturally through photosynthesis. And our forests are already pulling their weight in this regard. Each year, globally, our forests take up somewhere between 1/4 to 1/3 of all of our global carbon emissions. So that's huge. And it means that we have to be really careful about maintaining that in-forest carbon sink by thinking about in-forest carbon stocks. And that has to do with how we use land, including the implications of the permanent loss of forests to development, but also where forests are actively managed, how we manage them. And we also need to think about the other side of the coin. So what's the fate of the wood products that come off of those well-managed forests? And how can those wood products potentially help us mitigate climate change? Next slide, please. So this one, it's too bad this one's not animated for you because this is a fun little GIF where all the little people are moving and the little balls are moving across the screen. But the reason I put it up is because if we want to think about how we do this, it really requires recognizing that climate change is a complex systemic problem, as I mentioned at the beginning. There are a lot of interacting components. It's like a giant Rube Goldberg machine. And it's a tricky problem to solve because it touches on almost everything from how we use land and grow our food, how we power our industries, how we get from point A to point B, how we build our cities. And if we only focus on one part of the system, like the little box you see in the center there, we can't really change the trajectory of the entire machine. It's really essential that we sort of expand that frame and look at the entire system. So just imagine that red box expanding to cover that entire graphic. And that's what we have to do if we really want robust solutions to climate change. Next slide. So when it comes to the forest sector, taking a systems approach means thinking about the entire forest landscape, which includes wildlands and reserves, but also managed forests and the associated forest product sector. And so we have to address all 3 of these components if we want to be successful, meaning we have to stop or at least minimize the loss of forests to other uses so we can maintain that in-forest carbon sink. Where forests are managed, we have to manage them well with an eye toward storing more carbon on the landscape and managing for more high quality, long-lived solid wood products. And then we have to use those long-lived wood products to substitute for more carbon-intensive materials. And if we do all this, we can achieve a pretty big climate wedge. And so what do I mean by that? That concept of a climate wedge comes from this 2004 paper. And this figure from the paper kind of illustrates the concept nicely. So you see that top black line with an arrow going up and up and up. That represents what emissions would be doing over time if we did nothing differently, just business as usual. So if we want to stabilize concentrations of CO2 in the atmosphere, say around 500 parts per million, we'd have to deploy a number of different wedges to get us from here to there. And that's not even thinking about going to negative emissions and kind of undo what we've done. And so the wedges here would be things like increasing energy efficiency in buildings, reducing the use of vehicles, using solar and wind instead of coal power, reforesting certain areas. There is no one silver bullet solution. And so we really are going to need to deploy a whole bunch of different solutions to get us there. And so what I want to talk about today is how building with wood, when it's combined with these other elements, can help us achieve a pretty significant climate mitigation wedge of our own. Next slide. So if we're going to talk about forests and carbon, it's worth taking a moment to just step back and consider the two separate questions of carbon storage and carbon sequestration, and how forests of different ages have different strengths in terms of these two factors. So the figure you're seeing here is from a really great publication that, if you haven't seen it, I highly recommend that you check it out. The link is right there. It's from folks at UMass and the University of Vermont. And this is sort of their carbon clock diagram. So it starts at year 0 at the top, going up to 400 years of age as you go around the clock. And the outermost ring is showing the amount of carbon storage. And so you can see that color gets darker and darker. So as a forest ages, it stores more and more carbon, you know, in the trees, roots, the branches, the leaf litter, the soil, the roots, the downed woody debris. And so it's true that older forests tend to store more carbon. But then if you look at the next ring in, the green one, that's showing changes in carbon sequestration over time. And so it's not sort of the amount of water in the bathtub, it's the rate at which water is pouring in from the faucet. So how quickly forests are taking up CO2 from the atmosphere and converting that into woody material. And what you see is that in our region, there's sort of a sweet spot between about 20 to 60, 70 years of age in which forests are sequestering the most amount of carbon. And that sequestration continues over the life of the forest, but it begins to level off as forests and individual trees begin to age. So the kind of exemplary management that I'll talk about shortly involves thinking carefully about balancing these two things, storage and sequestration. And if we harvest some solid wood products and store that carbon long-term in, say, a building, we can sort of reset that sequestration clock without releasing a lot of that carbon that we've removed into the atmosphere. Next slide, please. So I wanted to walk through each of these components with you. The first, again, is ending the conversion of forests to other uses. So whether we're talking about deforestation in the Amazon or development closer to home, in either case, the loss of that forest cover has an immediate emission of carbon to the atmosphere, but it also means that we lose the ability to store more carbon on that piece of land in the future, because forests are one of our best land uses, actually, from a carbon perspective. Next slide. So the good news is that this land conservation work has been underway for decades. There's a robust land conservation community in New England, and that work, of course, needs to continue. And New England Forestry Foundation is just one example. We've conserved over 1 million acres across New England since our founding. That includes lands that are held in fee, but also many lands that are where NEF holds a conservation easement for private landowners. And since we're in the Connecticut context, you can see highlighted there on the map the 4 community forests that NEF holds in Connecticut. But it's worth noting that land conservation is, of course, a key strategy here, but land use policy is also really important. It's not something I'm going to get into today, but you know, how and where we develop is just as important in terms of its impact on the land carbon sink, the forest carbon sink, as permanent land protection. So that's something to keep in mind as well. Next slide. So this brings me to the second piece of the puzzle, which is managing forests better. And first I should qualify, what do I mean by better? I mean forest management that really addresses that critical 20 to 30 year climate mitigation window, you know, while still providing wildlife habitat and the production of high quality wood. And it means that we can address climate change by improving how we manage our forests, by maintaining or increasing the level of stocking and increasing forest productivity through management. And so some of you may be familiar with the changes to the land study from folks at Harvard. And they modeled a couple of different future scenarios that you see in this graphic. And the forest as infrastructure scenario, so each one involves Each scenario involves a different level of harvest with different forestry practices. Forest as infrastructure, which you see on the far right in that green box, in that scenario, they were able to model a future in which we harvest twice as much wood, but we maintain almost the same amount of carbon in living wood as you would in the sort of business as usual recent trends scenario on the far left. And the way that's done is through the adoption, widespread adoption of what they call improvement forestry. So in this case, that means forestry where the objective is to improve the quality and the value of the timber by promoting forests that are comprised of large trees of species that have high economic and ecological value. Next slide. And this is a really important point because, as I mentioned before, our forests are being asked to kind of do both simultaneously. And a question that kind of comes up often is it actually possible to have our forests help us mitigate climate change by increasing carbon storage while we're also harvesting wood products for use? And the answer is yes. We've started pulling together some real world examples to try to illustrate this point. And that's what you're seeing in the graph here. And so I'm sure the numbers probably look quite small, but it's really just the visual that I think makes the point. So what you're looking at here are 5 different properties. 4 of them are NEF properties. And for each one, there are 3 bars. The first bar on the left shows the initial stocking in year 0. So the amount of volume of wood on the land. And then the bar next to it shows the stocking after 30 years. So how much the wood volume has increased or decreased over that time. And you're seeing saw timber in dark green, pulpwood in light green. Unfortunately, for some of these properties, back in the day, sometimes people didn't even record the pulpwood volumes because it was so low value. So we are missing some data there. But even if you just focus on the dark green, the saw timber trends, what you see is that in every case, the stocking increased over time. So the volume of wood on the land went up. And we could just as easily convert this from cords per acre into some measure of carbon. But the key is the third bar in each one of those groupings. And that's the amount of wood that was harvested off of those same lands over that 30-year period. And so really what it illustrates is that with the right kind of management, it is possible to increase that carbon stocking on the landscape while we're still able to harvest wood products. Next slide. And so NEF has been working for several years actually to try to define what that kind of management would look like, to define the kind of management that it aspires to practice and has been practicing on its own lands for many decades, which we call exemplary forestry. And one of the things that's unique about it is putting this role of forests in mitigating climate change co-equal with more traditional forest management goals like enhancing wildlife habitat and increasing the quality and quantity of wood. And it starts from a landscape perspective, recognizing that you can't really achieve certain ecological goals, particularly wildlife habitat goals, if you don't think about how a particular parcel of land fits into a larger context. So, if you are thinking about what to do on one large contiguous block of forest in an otherwise fragmented landscape, then your management decisions are going to be different than if you were in the opposite context. And if you go to the New England Forestry Foundation website, you can find a copy of these standards that have been developed for the Acadian forests of Maine. And we're currently in the process of developing a complementary set of standards for the North Central Hardwoods region of Southern New England. So the concept of exemplary forestry is the same in both cases, but of course the forest types, the wildlife species of concern, the context is a little different in Southern New England. Next slide. So one of the things that the folks at NEF have been doing is trying to quantify what would be the carbon implications of practicing this kind of forestry. And some initial calculations suggest that practicing this kind of forestry in Northern New England alone could store an additional 1.9 gigatons of CO2 in living wood. And that's equivalent to taking every car and truck off the road in New England for 20 years. So it's not small potatoes. The take-home message here is that if we change how we manage our forests, we're talking about big implications for carbon and climate. Next slide. So that brings me to the third piece, which is long-lived wood products. And I want to just take a minute to kind of talk about why that's an important piece of the puzzle. So the first reason is that, wood can substitute in many instances for more carbon-intensive materials like plastic, steel, and concrete that take a lot more energy to produce. And so whenever we're using wood as a substitute, we are avoiding the emissions associated with the production of those higher energy materials. Plus, wood is primarily carbon, and so we're actually able then to store that carbon long-term in the products themselves, whether that's flooring in your house or the studs in your walls, or the desk that I'm sitting at right now. But if we're going to talk about how wood is a more renewable material, we do have to think carefully about where that wood comes from and how do we source it. And so I'd like to mention this, this really important publication. It's almost going on 20 years ago now, called The Illusion of Preservation, which really kind of made this case and outlined why this is so important and the tension that can sometimes exist between production and consumption in our area. And so I'll just read you really quickly this quote from the publication, where they say that reducing domestic production with no corresponding change in consumption simply requires other parts of the globe to supply the resources. Natural resource preservation is but an illusion if it only serves to shift the source of the resources, especially to locations where extraction is less environmentally sound. So in order to achieve true environmental protection, it's essential to consider both consumption and the global distribution of resource production. And this is just never more important than in an era of climate change, when what really matters is what the atmosphere sees in terms of emissions. So if we're using products in our region, but we're not producing them here, then those emissions are still happening, they're just happening elsewhere. And I think we all have a responsibility to try to avoid outsourcing the impacts of our demand. And so there's a real value in sort of growing what we need where we live in our local region. Next slide, please. So one particularly exciting long-lived wood product, I would say it's new, although they've been building with this material in Europe for decades already, is mass timber. So mass timber is a term for a whole suite of engineered wood products that involve taking small pieces of lumber and gluing them together to form massive, hence the name, timbers that are really strong, but also relatively lightweight. They have a great strength to weight ratio, and also fire resistant, in part just because of their sheer mass. And so in the image on the left, you can actually see a couple of different examples there of mass timber products, including cross-laminated timber or CLT panels, and glue-laminated or glue-lam beams. And you can use these materials to build buildings that really have a beautiful aesthetic, like you see on the right. And there's lots of anecdotal evidence, some scientific evidence, that people respond really positively to living and working in environments where they're exposed to wood and natural materials. I've had more than one architect tell me that they have seen people hug wooden columns, but they've never seen a person hug a concrete column. Next slide, please. So I'm focusing here on one particular application of long-lived wood products, which is wood buildings. And you might ask, well, why focus there? And the answer is because we will need more housing for more people in the next few decades. As an example, the Metro Mayors Coalition estimated that an additional 185,000 housing units would be needed between 2015 and 2030 to meet demand or reduce or at least stabilize housing costs. So this is an example from the Boston area, but certainly we can expect to see similar demand for housing in other urban areas of New England, including in parts of Connecticut. And if we build all of that new construction with concrete and steel, we will cook the planet. We need a better alternative. Next slide, please. And there are a number of different reasons why, from a carbon perspective, mass timber is a better alternative. So the first, and I've touched on this a little bit, is that there are lower emissions associated with this type of construction, and that's because it has lower embodied carbon. And oftentimes when we think about emissions, we talk and think a lot about operational emissions, so the amount of energy that it takes to run things, to keep the lights on and the air conditioning and power this computer. But embodied carbon has to do with the amount of energy that went into the production, manufacture, the transportation of the materials that we use to make things. And so as you can see here in terms of water pollution, fossil fuel consumption, smog potential, wood just has a much lower impact than concrete and steel. And in fact, concrete and steel account for about 11% of global emissions every year, which if you think about it, is actually a really large slice of the pie for one sector. So when we're able to build with wood in the right context, we are avoiding all the emissions associated with concrete and steel that might have been used instead. Next slide, please. So you might be asking, well, what's the potential here? And we actually have a couple of global studies that we can look at that have tried to estimate how much we could reduce emissions by building this way. There was a paper by Oliver et al. In 2014 that estimated, depending on the efficiency of wood use, somewhere between 14 and 31% of carbon emissions could be reduced. A more recent paper by Shakun et al. Found that with a strong transition to wood buildings over 30 years, you could reduce global carbon emissions by about 4%. So these studies have different methodologies, approaches, and there's quite a range there in terms of the estimate, but they agree on the sign. They agree that there is a potentially positive impact from this kind of construction if we take it to scale, and the impact is not small. And of course, many of you are probably familiar with tools like life cycle assessments, which are able to look at the carbon implications of individual building projects compared to the alternatives. And there are a number of those we could point to for individual buildings. NEF actually has an LCA that's currently underway to look at the carbon impacts of building a mass timber building with New England wood in Boston. And there'll be follow-on work to that to look at what are the impacts at different levels of market penetration for mass timber construction in our region. So there's definitely more work to be done to really nail this down and put some hard numbers on what the potential is. But it's still an exciting opportunity potentially. Next slide, please. So another benefit to building with wood is a concept that we've hit on, that you're then storing carbon in the building itself. And so you're taking carbon that was stored sort of on the stump and instead storing it in your city. And one of the things that's really interesting to think about is that in New England, a lot of our urban areas used to be forests, right? So they actually had a lot of above ground carbon. And in some ways, by building this way, we can sort of put that carbon back on those acres. And the image that you see here is of Brock Commons at the University of British Columbia. It just as one example. So there's over 1,700 metric tons of CO2 stored in the wood of that building. And another interesting point to make here, I mentioned at the beginning that there's an increasing level of disturbance in a lot of our forests driven by climate change. And so that is leading to a situation where we may not be able to guarantee that in-forest carbon sink will be stable over time. California is a great example where that forests have turned from a carbon sink into a carbon source because of that combination of drought, extreme heat, pests, and of course, land use history. And so, the Cherkina paper that I mentioned, in there they have a statement where they mention that transferring carbon from forests into cities may compensate for the weakening of the land-based carbon sink. So that's another interesting wrinkle to think about here. Next slide. Lastly, building with wood also means that we can potentially have a different pattern of development. Because it's not as economical to build with concrete and steel in mid-rise construction. So what we end up with is a lot of light frame wood construction in suburban and rural areas, and concrete and steel high-rise construction in our cities. And we're left with sort of a gap in our housing stock. And that's something that mass timber construction can help fill. And what that means is that we can build more densely in urban areas near transit hubs. That helps put more housing supply where it's really needed, which helps with affordability. And it also reduces sprawl, which then helps reduce transportation emissions associated with people commuting to distant jobs, and it reduces the development pressure on forests in that sort of exurban edge. So there are a whole host of sort of follow-on effects in terms of additional carbon savings beyond just thinking about the carbon in the buildings themselves. Next slide. Because we're talking about mass timber buildings, Chris made the excellent suggestion that we should point out some of the buildings that you've got there in Connecticut if you want to go check out one of them. One is the Mill River Park Carousel Pavilion in Stamford. If you just Google it or if you've been there, in particular, the ceiling in that space above the carousel is like a work of art. It's really cool. Also, there's the Thompson Exhibit Building at Mystic Seaport, which is a stunning architectural design. And it actually just recently won an award from the Connecticut Green Building Council. Another really interesting place is the Common Ground High School in New Haven, which is a mass timber building. And that's what you're seeing images of that school there along the bottom, which is a really great place. And, students can sort of connect with where the material came from in their building. And the architect has mentioned they even comment on how much they like the smell of wood in the building. Next slide, please. So I also want to take a moment to mention what kind of timber species we use to make mass timber, because some of you may be wondering. Mass timber is made from softwood lumber, so think pine, spruce, and fir species. And on the map on the right, you can see where that forest resource is in New England. So in the blue, you're looking at your spruce fir forests. They're primarily in northern Maine, but also other parts of northern New England. There's also some interesting new research out of Peggy Clouston's lab at UMass Amherst that suggests that hemlock could be a potential for use in structural CLT. And you can see in this forest type map that there are quite a few forest types in southern New England that have hemlock as a component. So that's potentially interesting as a source of material for this kind of building in the future. Right now, about 63% of our softwood lumber comes from the southeastern US. And that's also a region that has about 70% of the plantation forests in the US. So a lot of that wood is coming from plantations that are intensively managed. And another 29% comes from the West. So from the Rockies, the West Coast, and Alaska. Next slide, please. But talking about that leads me back to hammer on this point once again of taking a systems approach, a systems perspective, because the carbon benefits of this kind of wood construction really hinge on the sustainability of the sourcing of the material. So as an example, the Oliver paper that I cited previously presumes that harvesting is limited to growth on an annual basis. So in places where harvesting greatly exceeds growth on a landscape scale, you're creating a carbon debt that can in some cases either certainly reduce and sometimes eliminate the carbon benefit you're getting from this construction. So it's really important that this is tied to sustainable management, because you can't really have one without the other. You can't have your sustainable wood building without your sustainable wood sourcing. Next slide, please. So I mentioned at the beginning that we could potentially put all these pieces together to form a pretty significant climate wedge in our region, with the combination of the building sector and the forest sector coming together. And so what you're looking at here, and this is just a schematic, there's no absolute numbers attached to this yet, but you can see there's a flat line where current emissions are. That top line would be, what emissions would be doing if we did nothing different. And you can see that if we improve the management of our forest land, there's a savings there. If we take some of that harvested wood and we store it long-term in big wood buildings, we can get another wedge there. If we avoid the loss of forest carbon, and then if we don't use concrete and steel, then we avoid all the emissions associated with that concrete and steel production. And so, this kind of gives you some sense for what we're talking about when we say that if you put these pieces together in the right way, you can achieve a pretty big climate wedge. Next slide, please. So just to kind of summarize there, you know, in addition to achieving that climate mitigation benefit, this way of approaching things also puts forest products at the center of climate-driven development. And that certainly helps support forest-based jobs in rural communities. You know, as we said, it means we can build more housing where it's needed, and that will help with affordability issues, and simultaneously help improve mobility and reduce future sprawl. And when you're doing that and you're sourcing that wood from, you know, well-managed, responsibly managed forests, you're still able to maintain wildlife habitat and clean air and water, the kinds of ecosystem services that we rely on our forests for. So there are a whole bunch of co-benefits from this approach beyond just the question of carbon, which are all equally important. Next slide. So you can't see it because it's hidden. I would have had it under the animation, but I was going to show you that Rube Goldberg schematic again with the big frame around it to kind of remind us that if we want to take this approach, we have to have that big picture frame. We have to think about the whole system. And, you know, if you know, the next question then becomes, well, how do you put that into action then? How do you actually take a systems approach? And we say that because you have to recognize that all those pieces are interconnected. Like I said, you can't have one without the other. So you can't have, you know, truly climate-friendly wood products for buildings if you don't have a local wood supply, because shipping in wood from a world away has high transportation emissions. But you can't have climate-friendly wood products if you don't ensure that they come from well-managed forests that continue to store carbon and provide those other forest ecosystem services. But you can't practice good forestry without land conservation, because in an ever more developed and fragmented landscape, harvesting becomes logistically and financially impossible. Nor can you have policies that incentivize low carbon construction if you don't have a certain level of political support. So if we realize that you know, wood buildings need to be connected to sustainable sourcing, then we have to take a cross-sector approach. And so the big picture message here is that solutions that really recognize how the natural, economic, and socio-political systems are connected to each other is really the only way we can tackle a problem of the scale of climate change. And so I wanted to end with just one example of how NEF is trying to kind of embody that approach. We have an initiative called the Forest to Cities Climate Challenge. And like I said, you know, we recognize that, wow, there's a potentially great climate benefit to building with this kind of construction, but it has to be linked to, you know, excellent forest management. And so we realize that we can't just talk to our usual forestry conservation crowd. And so we're working to reach out through this effort to architects and engineers, you know, housing advocates and other sustainability folks to kind of bring everyone together to kind of bring this vision to reality. Because the reality is that these sectors are connected to each other, and if we're not working together, we can't achieve the maximum climate benefit that we're talking about here. And so if you're curious about that as an example or learn more about it, the website is there, foresttocities.org. That's one way we're trying to take this big picture systems view for a forest organization to kind of stretch beyond our bounds and maximize our impact. So yeah, that brings me to my last slide, was really just to tee us up for questions. So I appreciate all of you listening in and being patient with our technical difficulties there at the beginning.
Jennifer, thank you so much. That was really informative and touched on quite a few of the principles that the GC3 Forest Working Group has been wrestling with recently. So it's nice to have that presentation today. We do have some questions, and what I can do is I will use that question and answer tool and read those questions aloud so all can hear them and maybe even see them if you hit the button. And Jennifer, if you'd like, you know, once they're read, you can respond.
Sounds good.
All right, so first question we have, and please keep them coming in, we have time. How do you decide which trees to remove to use for wood products?
Yeah, that's a great question. And it's really at the heart of, what it means to sort of do good forestry is to think about what to cut and what to leave. Because obviously you're thinking not just about the products and the income, but you're thinking about what do you want to leave behind so that that future forest is even better than how you left it. And so, it really depends on the goals of a particular harvest. Sometimes in, say, like a pre-commercial thinning where a forest is kind of overstocked, you may be taking out smaller or diseased or suppressed trees to make room for the ones that are growing vigorously so they can grow bigger and faster. And then you might take those out later on to create openings to get more regeneration started on the forest floor. So it's, in some ways, it's a complicated question of what do you choose to take or leave, but really foresters are always thinking about both of those things, right? Which is the products that they're harvesting, but really the future stand condition in the forest. Hopefully that answers your question.
All right, thank you. Next question. Do federal or state incentives exist for developers and perhaps city planners to use wood products in construction, building mass timber buildings?
We don't have too many examples of that in the United States, but there are examples in other countries like New Zealand, and France just passed something recently requiring new buildings to, I think, there's some percentage that of made of natural material, including wood. And I know even within the GC3 and the buildings group, there's talk about, creating incentives for lower embodied carbon construction. And so I think that's where the wood building stuff could really shine, in particular, because it has lower embodied carbon. When we really start thinking about the carbon that goes into the materials that we use, that really on its own kind of incentivizes wood use. And so there are a whole bunch of different interesting policy mechanisms that we could use potentially to incentivize this. And primarily at this point, we can look to some other parts of the world that have done that and see what we can learn from those examples. So that's a great question.
Yeah, and I can't help but chime in. I think another avenue is leaders on different executive boards can help steer decision-making on new construction. And another example in Connecticut is the Connecticut Agricultural Experiment Station's Lockwood Farm, where the governing board there wanted to build a pavilion at Lockwood Farm and purposely chose locally grown wood, pine and white oak, to make that. And it's a beautiful structure. If you're ever in Hamden, Connecticut, and the Lockwood Farm, it gets a lot of use. It's ginormous. Okay, next question. Do estimates of reduced carbon from mass timber consider the CO2 equivalent emissions of its manufacture, which involves glue and can require shaping with heat and steam?
Yes, absolutely. The comprehensive assessments, which are the ones we should be looking at, will do kind of that full big picture look at all the components. So, obviously there are also emissions associated with the machinery we're using to cut the trees and the log trucks that move it to the mill and the mill itself. And then when you get to the manufacturing facility where you're producing something like CLT. So yeah, you're absolutely right. There's emissions sort of all along the way. And so absolutely those would be accounted for because it's really the only way to make it sort of apples to apples with other types of materials. And one other thought, just related to the last question, I realized as I was moving through my slides, one thing I completely neglected to mention for all of you is that there are some recent changes in the International Building Code that actually allow mass timber construction in the US up to 18 stories. So that's also one of the reasons why now is a great time, because now it's possible to build bigger with wood in a way that we really couldn't before. Oh, Chris, I can't hear you if you're giving me a question.
Okay.
I'm not
Sorry
ignoring
about
you, I
that.
swear.
All right, I think I got my connection back here. Sorry. Is anyone citing or planning to establish a mass wood production facility here in the Northeast?
Yeah, good question.
Yep, go right ahead.
So the answer, I think, is yes. It's all but inevitable that we will have a facility. And it's a good question because to the point, we don't actually have one here now. So there's a bit of a chicken and egg challenge ahead of us with some of the stuff I laid out here, where at the moment, if you wanted to build a building like this, you'd be bringing in material that was, I think the closest mill is in northern Quebec. Some panels come from Europe or from the Western US. So definitely there are a number of different firms looking at siting a plant in New England. Maine is a particular hotspot in part because of where the spruce fir resource is located. But you know, some of the time those projects, they're big and they're big capital investments, and so they fall through and new things come. And so unfortunately I don't have any you know, solid timelines for you, but I do hear from lots of folks that that's definitely coming down the pipe for us.
All right. Next question. Does New England Forestry Foundation also advocate against bad forestry practices?
I mean, I would say so, in the sense that that's why we worked so hard to try to define what exemplary forestry looks like and practicing it and modeling it out so we can quantify, you know, what the real difference is on the ground in terms of the forest that remains and the products that are coming off of it. But yeah, I mean, certainly that's really important because, you know, one of the things we're also talking about a lot lately is what does it mean to do sustainable forestry? And perhaps we need to start rethinking a little bit what that definition means in an era of climate change, especially if we want to make a difference in that 20 to 30 year window. And so that gets a little bit tricky sometimes, but I think absolutely there's a whole range of practice out there. A lot of forestry in our region is really, really great. But if we care about climate, then we might have to do things a little bit differently.
All right, and I think this next question ties in well. So the comment is there's a total agreement that the biggest carbon benefits are preventing conversion or improving the management in areas that are poorly managed. For climate benefits, this active approach needs to be coupled with growing intact forests wherever possible. Systems approach requires understanding the entire system, and there are lots of variables and unknowns. We do know that nature stores the highest total carbon in biodiversity, and it evolves at a faster rate under stress. So it's important to balance natural areas with resource areas and also support ongoing research. And the responder is really pleased with New England Forestry Foundation's supporting both. But the question here is, with that backdrop, what is the gap between wood production and consumption in New England? And there is reference that the illusion of preservation was based on Massachusetts, which is a small, densely populated state. Yeah,
that's a great point. Wholeheartedly agree that we definitely have to have a balance of reserves and working lands. NEF's definitely on board with that. You know, each one of the states, including Connecticut, that are going through these policy processes right now are wrestling with what that proportion should be. And we can bring some science to bear on that, but in some level that starts getting into some value questions too, but absolutely it's a balance. And in terms of, sorry, Chris, I mentioned that and I just lost the train of the last actual question there.
Yeah, sure. So it has to do with the New England wood consumption and the production. So what is the gap between wood production and consumption in New England?
Yes. Okay. Actually, I had a little graph of that I had on a slide, and I deleted it. I should have left it in there. You know, it depends on the state. Some of the data that I was looking at recently was a little bit dated, so kind of like from the mid 2000s, showing that the north, which they did by Forest Service region, so it really included sort of New England into the Midwest, had the biggest gap between consumption and production of any region of the US, which isn't altogether surprising. We're the most population dense part of the country, but we're not the biggest timber producing regions, which is the Southeast and the Pacific Northwest. So there's a pretty decent gap. I wish I could have the exact number for you off the top of my head, but we're not we import a decent amount of the wood that we use. I think for Massachusetts, it's something on the order of like 80 to 90% of wood that Massachusetts residents use comes from elsewhere. Unfortunately, I don't know the exact numbers for residents of other states, but the U.S. is a net importer of certain wood products from other parts of the world too. So there's a gap there for sure.
Right. I would guess Connecticut's probably very similar to Massachusetts, as our population's very dense. Okay, next question. And these are excellent questions too. It sounds like a lot of carbon storage and sequestration models are focused on above ground biomass. Is below ground biomass taken into account with these carbon models as well?
Yeah, that's a really excellent point. It really depends on which study you're talking about and which type of analysis. Not always. The below ground carbon piece is certainly more difficult to measure and model, but so in some cases that would be taken into account, but not all cases. So it's sort of difficult to say, and I'm actually forgetting off the top of my head if some of the studies that I shared with you all today actually include that piece or not. Certainly the roots, so like below ground carbon from the trees themselves are often taken into account, but then there's also carbon in the soil itself, and so that's the trickier piece to actually measure.
Okay. There was a question that came in on the chat, which I want to try to get to. And the question is there any research on using hardwood species for mass timber? Connecticut is predominantly oak, forest hickory type. We do have some pine and hemlock, but not a major component. How does forest industry support this movement and source local forest products without solely focusing on harvesting on softwood species? And again, the additional markets for hardwood species may be beneficial to help move forward with this.
Yeah, that's a good question. My understanding is at this point, anything involving hardwoods is sort of in the experimental stage. So certainly there are a number of labs. There are folks at UMass, like I mentioned, but also University of Maine has a really big wood composites lab that studies a lot of this stuff. So people are experimenting and testing with the use of hardwoods, but at this point, there's no commercial manufacturer that I am aware of that involves hardwoods. In part, they're just heavier, so that does kind of affect that strength-weight ratio, and I think they just perform differently in terms of the glues and the drying process and that kind of stuff. I'm certainly not impossible. I do hear people talking about that, but it seems like that's probably a little ways off if that ever happens.
All right, and we're getting down to the end here at close to the top of the hour. Oh, another good one. So what is the net carbon in cross-laminated timber versus wood itself if it is in a long-term product? So I guess additional manufacturing for CLT versus a cant of wood maybe.
Gotcha. I don't have a specific number, I guess, for that question. If I'm understanding it correctly, I think, wood, when you take it off the stump, is a lot of it's water. That weight is water. So then there's certainly a drying process that happens, and so carbon per unit of weight is different. Would be certainly I don't know if that quite gets at it, but certainly to the point I made earlier, there are definitely emissions associated with the extraction, transport, manufacture of the engineered wood product itself. And so it's obviously not like a one-to-one, because the carbon that was in the wood in the forest, you certainly have to deduct those emissions from that total carbon savings in order to get to like what is the real carbon benefit of using that CLT. And so, but that is something that's accounted for when people kind of look at the big picture carbon savings from building with this stuff. Hopefully that kind of answers the question. Sorry.
Yeah, and I think it gets back to your point, Jennifer, where we're really not so much talking about stick book, single family residential homes, but more or less concentrated housing in urban areas where infrastructure currently exists and that infrastructure is starting to fail. And so what are you going to replace it with? And is your choice wood, steel, or concrete?
Yeah, exactly. That's really the trade-off that we're focusing on in this case. And certainly there are some examples of some architects who are thinking about even sort of retrofitting or adding on to older buildings. Like because this mass timber stuff is so lightweight, you can actually sometimes add additional stories, for example, on top of unreinforced masonry buildings. So that's a pretty cool option in some places. Like if you think of Boston, there's so many beautiful historic brick buildings, and you can actually add additional density without actually increasing the footprint of development in those places with mass timber.
All right. Well, we are at 1 o'clock, and I think we've covered everyone's questions. Really appreciate everyone's active participation. We had over 40 on the webinar today at one point or another. And I'll just point you, I'm also going to set Jennifer up here. Her contact information is on the last slide. So if you want to follow up with another question or the answer you got really wasn't exactly what you were hoping or looking for, Jennifer's is available. And if she's not, she'll shift the question to me, but I'll get an answer for you. Jen is more than qualified to handle questions and carry on the conversation beyond from this 1 hour today. So
Absolutely.
I guess with that, we'll wrap it up. Jen, thanks once again for helping us wrap our arms around this concept of more wood and more forests and how we can have both. At face value, it doesn't make sense, but I think you explained it really well today.
Great. That sounds wonderful. And yeah, thanks everyone for tuning in.
All right. Well, thanks all, and have a wonderful afternoon. We'll close out this webinar for today on the climate series.